Today, I want to discuss repeated measure ANOVA, right? So for that, we have to understand what is this repeated measure ANOVA. Okay, so repeated mean to say which study and which experiment or which tasks are repeated. In that case, we can use ANOVA in different manner for repeated measure ANOVA. Basically, every test compare the mean, as you know very well, repeated measurement ANOVA test. So see, so what it does for us, it will explore the impact or whatever effect of the target variable, dependent variable. Target variable is the dependent variable, and effect we can check on the independent variable, right? Independent variables. So it can be used to analysis the only experimental study. If there is some experimental study happens, in that case, we can apply this test for analysis of the data. And the rules and mean to say assumptions, you know very well, normality, because we are using the parametric test. So no data should be normal. I think you did well in the test. You remember what is the normality? You did well. Normality and sphericity and the outlier and another dependency and independence variables, we can check it. These are the some basically sphericity is just like the equal variance, but here we have some three groups. We can use sphericity and we will see when the result comes out, you can understand more, but you can Google it and see what is that one. Okay, it is for the variances. Okay, so let's see, we will take the one case study. Okay, let's go to my notes here, and we have the parametric test, and this is the ANOVA and repeater measure ANOVA, right? So let's open the case study. So I'm opening the case study. So case study mean to say we have some study example, that is a diet, right? Diet study. So suppose there is a dietitian introduce a new diet chart plan to remove or reduce the weight loss, right? Because nowadays everybody want to stay healthy, right? In that case, they took some study, they made some experiment on the 15 ladies, women, just this is a hypothetical study, 15 women who consider themselves to be in need of losing the weight, right? So they put them in a diet for 2 months. Oh, yeah, right? So dietitians give you advice, you have to take this diet if you want to lose your weights. This is the that study. So their weight was measured in the kilograms, the start of the diet, and the after the 1 month or 2 months or 3 months, they check what was the effect, right? The weight is reduced or not, right? So in that case, you will see there is a concept of before and after. In that case, I think we can apply which test, repeated measure ANOVA. We cannot apply the only ANOVA. Clear? You see how the study is. So let's go for our sample data. Can you see the diet sample data is here? I'm opening the samples in front of you. You will see it should open in the IBM tool and you can easily check it. Let's see how it look like the data. We have a 15 ladies data, 15 women. So let's see what it showed to us. So have a look here. It is going to be loaded now. Maybe very few seconds it will be loaded. Yes, I think it is loaded. Please have a look, right? Please see, this is a baseline. Baseline mean to say when initial weight, you know, what was the initial weight? This is like a baseline variable. So suppose this lady number one here example in the starting weight 105. Okay, and they took some diet, and prescribed by dietitian. And after then, what was the new weight? 98. It is reduced. And second month, more reduced. And third month, more reduced. Can you see for this record? Let's go for the another record. This one last. So in the starting, she has 92, then 84, 78, and 65. If you will see this data, you will see, sir, yes, in the last 3 months, weights are extremely reduced. What does it mean? It means to say the diet plan was affected. Okay, but we cannot see on this data. We have to do the some statistical test. In that case, we can apply the repeated measurement ANOVA, right? So the question can be, what is the impact of the diet on the losing the weight or reducing the weight? So whether the dietitian use a real good plan for reducing the weight or not. So we can take a decision, right, based on that. Okay, so we have to use a repeated measure ANOVA. So let's see how we can use. So first of all, right, and how we can check the normality. We can go to descriptive and explore, right? So we have 3-day data, first day, second day, and third day, right? This is the weight actually. And we can check by the weight with the normality graph here and go it here. And if you have some missing value, you can use it here, otherwise no need. So I think it is okay. And if you want to check outlier, it is okay, but it is not important now. Let's check the normality of these 3 days data, right? So we will directly goes to where normality functions, and we have this normality functions. Please have a look. You can see the first month data is again a normal, right? Because value is bigger. Okay, it is a significant. For the second is also one, and so practically this 3 month data is a normal. Okay, so what does it mean? We can use this data, right? Check it. So I put it here in the chart. The data is normal because the value of is 0.5. So just because of the that one. So now I think we can use this data, right? Okay, now we will not go for the as I told you, because we have not a two groups here example and no another things. So equal variance is not important. We can use a, because it is ANOVA, so we should go for the sparsity, which is going for within the group, right? Okay, not between, it was the within the group variance check. So that is called the sparsity. Okay, so how we can apply the repeated measurement ANOVA? In your slide, you can see we have a basically few steps. First, 2, 3, 4, 5, and not 6. I think these steps we can implement it. Let's see how we can implement it. First of all, where we'll go analyze, and you will see where is the repeated measure in a general linear model. You will find here repeated measurement. This third option, please check it. Now you will find a dialog box here. We have to check how many level we have. Basically, for a weight, you can give a weight here, VEIG weight, and level depending upon our data example. How many level? 1, 2, 3, 4, right? Including the base, you can write, and we can add it here. Okay, so measurement is not more interesting here, so we can do that and define it. After defining it, you have to set your variables, which are the basically target variables. So here we have all the target variables. So we will go for our 3 target variable, because baseline we will not include here. So let's see, we will take all the variable there, right? Okay, so you can control A and you can take all together here. Okay, now next you can see model. Model is by default, it is a fully factorial model. You can go for a contrast. I think in a contrast, we can check weight polynomial, because we don't want to apply this one, or ANOVA technique. Variance technique is the repeated. You can see this is a repeated measure ANOVA. If you want to go polynomial ANOVA type and simple deviations, there are different methods. But in our study, we have a repeated measure ANOVA. You can continue it. Okay. And next, post hoc test. You can apply any post hoc test, but it is not important here. And next is the mean. You can check it. Control A, and you can take to that one. So this is the repeated measure estimate of marginal means, right? And you can select a compare mean here, and here you have to check Borfoni test here, right? It is a post hoc test, you will see here, right? And if you want to save some value, standardize or unstandardized, you can save, but we have no need, because we want to just check the our results. So now I think it is enough. We finished all the In the options, we will have some descriptive statics. This is optional. Homogeneity test. This is the homogeneity. I show you equal variance. You can check it. Another test if you want to apply, but for the repeated ANOVA, we have only these two important. And the level of the accuracy and significance is 0.05. What does it mean? 95%. You can change, but by default, I will go with that. You please have to do the click OK, and then you can see the result of repeated measure ANOVA, right? So you will see we have this descriptive status. It will show here the initial weight of the ladies or women 1102. You will see it is a very high mean. This is the average. And after 1 month, after taking some diets, the weight reduced. And then second month again reduced. Third month again reduced. So practically it is going to be reduced, right? So we want to check, is there any difference or not? Is there any impact or not? So we can use it. So let's see here in my graph here. So we have a multivariate test. Okay, in a multivariate test, I show you we have a several tests. We will see here like a polite race, Wilks lambda, and another test we have statistical test. These tests are always, proving the value is 0.05 less than. It means it is a significant test. These all different tests are telling us the weight which we decided weight has an impact or not. So it is really impacted by the diet, right? So it means it is a significant. Really, the ladies' weight has been really reduced. Okay, so now next is you can see here there is an impact of a diet on the losing the weight, right? It means effective measurement was there. Why? Because the p-value is less than 0.05, right? Next we have, uh, I told you sphericity, which basically check the homogeneity, test of homogeneity within a group. Mean to say within a group there is a variance equal or not, like that. So you can also check with the mutually test of the sphericity. Okay, so have a look here. We have that one. Just you have to go for this significant value, but in this case the value is coming 0.009. So you will say, sir, it is like not a good value. It is saying that it is 0.05, not less than and not a greater than. It is less than, it should be greater than, right? So it is lower value from the 0.05. It is lower. If it is lower, it means to say there is no homogeneity, right? So in this data only take it. But in that case we can take another alternative. We can take these two values, right? These two values, suppose 0.581. You have to make sum of these two value and divided by 2, right? Test homogeneity within a group. In that case you can find the value is 0.61. In this moment the value is greater than 0.05. Okay, so you can use this data, right? Because I already check with this. Yes, if it is bigger than 0.05, there is no doubt you can use it. Okay, but if this value is goes low, in that case you can use these two different value of Hung-Feld test and Geyser test value. This is some statistical test. You can combine it and you have to divide it by 2, because you have to check the majority, right? Because you 50% you will take this and 50% value you should take this. That's why you can plus it and divide it by 2, and this value if comes above the 0.05, like zero point 0.5, above 5, then you can say uh, there is a useful data for analysis further. So you can show your results. So within a group there is a equal variance, you know but in a t-test we use 11a test. You remember l test, 11 test. But here we are using a ANOVA sparsity. We should not use a Levenet test. We have this Mukli test of the sparsity, right? So you please go for the internet and see the some theory about it if you want interested. But if you want to do the directly experiment, you can claim your results like that. So student, this is the basically way. And next is there is you want to show by the display where is the difference between the mean. Yes, obviously you can immediately click a chart over here. So suppose, so these two data, I think standard deviation we no need. You can delete it here. And now do select the data, do right click and create a graph example bar. Which graph you want to create, it should create for you, right? So let's see. it will create for us. Yes, can you see it is created now? Now you can print as much as you want. So suppose show the data label, you can show the data label. So basically this is the mean, and this graph is also showing there is a difference between the different different month wise weight of the women's, right? So first month in the starting they have a high weight. After following the diet plan, after 1 month it is reduced here again, and up to last month after 3 months it really works, right? So the dietitian plan was affected, right? So this plan can be used on the another group. Okay, so this is the student's result. So you can use in this type of a study which repeated measure ANOVA.